Okay, I've had a lot of requests over the years to help people find roll centers. I haven't done it in years. Um, I don't think it's necessary, really. If you buy a car from a manufacturer, they have it figured out. But I still get questions on the procedure and how I'd about finding roll centers on a car. So I'm going to lay out my entire strategy here and how I did it. I haven't done it probably since 2005, 2006 or so. But people still want to do it, want to learn, want to explore it. So I'm going to go through my whole procedure, lay it all out, and give you everything I got on how to find it. Now, I use software. I could go through the whole connecting the line thing, but there's other places you can find that, and preferably I would just get software because then the software will let you roll and everything else. So I'm going to basically, this video is going to be me going through my process to find the numbers and to set your car up to get those numbers to put into that software and start your exploration on roll centers. So let's roll the intro and let's look into finding a roll center. I've spent the last 30 plus years working on race cars, building race cars, and racing cars. And I'm here to help you better understand racing technology. Okay, I got some cheat notes here because, like I said, this video is going to be pretty long, pretty intensive. So I'm going to make sure I get everything covered uh, to get you where you need to be so you're comfortable with doing all this, all the stuff I do. I want to start off with a list of stuff that you have to have and have to do before you even start measuring anything. First thing you're going to want to do is basically figure out where ride height is on your car. This includes motor. If you want to put the driver in there, set it up like you take it out on the track. This includes tire squish. You're going to want to measure to the center of your hub, the center of where the tires go with all that weight on there, because you will get sidewall squish. So you're going to want to measure all this stuff, get proper ride height to put ride height bars in there, figure out how to build the ride height bars so you can take the shocks and springs off the car. Like I said, the center of the hubs, you're going to want to measure to that spindle height or maybe some lug posts or something so you know exactly the height of that hub is. And then you're going to want to probably make stanchions, and I'll do a diagram on how I make stanchions. But then you're going to want to take all this stuff off. You're going to want to take your shocks and springs off. You're going to want to take your body off, most of it, because you're going to want to crawl around underneath this thing, and you don't want body work, you don't want shocks or springs, you don't want a motor, you don't want a tranny. You might want a motor plate so you can drop a plumb bob off the center of the motor and figure out motor offsets. You're going to want to take your front bumper and nose off there. Probably, like I said, drivetrain, tranny, drive shaft. You're going to want to leave the rear end in there, and the center section, if you're running a mod, it'll be, quick change, same as a late model. You can drop a plumb bob off of it and find out exactly where the drive shaft is and everything on your rear end. You want to strip the car down after you figure out all your weights and tire squish and ride height down to a workable area so you can crawl around this thing, because you're going to be projecting a lot of lines, you're going to be doing a lot of measuring, and you don't want to crawl around unnecessary things like body work, motor, radiator, all those things that can get in your way. So first you find your car at ride height, tire squash, and then you take everything off, and that is the biggest portion for the beginning of it. Next, you're going to want to build your tire stanchions, and we'll go over exactly, I'll go into do a drawing on what they look like, but basically you're going to want to know where your caster and camber is, and then you're going to want, like I said, know where your exact probably studs are, where the center of your hub is. You're going to want to build a stand that will bolt onto the lug nuts and then let your car sit where it would be with tire squish. But the creative part of this is you're going to want to cut the middle out so you can still project a line through the center of the hub, center of the ball joints, and everything across the car. This will give you an idea on if your stub is turned, where your caster and camber, where your lower control arms sit. So you're going to want to build just like 2 arms down. I'll draw a picture. But 2 arms down somehow with the center you're going to want cut out so you can draw that line. The next thing you're going to want to do is you're going to want to figure out exactly where the center line of the car is front to back. I've done it a ton of different ways. If you know your stub isn't turned, like on a modified, you could use your inner pivot points. That seems pretty accurate. The center of those, draw a line across, or draw a line across in a 90-degree it. You can swing some arcs off of there, which is what I've done before too. You drop a plumb bob off the inner pivot points of your lower control arm at exactly the center. And then what you do is you go off of each side and you draw a big arc. You make to get yourself a pieces of aluminum and drill small little pinholes on either side, probably about 3 feet roughly. And you're going to want to drop a plumb bob off the center of that inner pivot of your lower control arm down to the floor, and you put a little pencil mark. And then off that pencil mark, you're going to want to scribe a line to the back, scribe a line to the front. It'll be in an arc like this. Then you go to the other side, and you do the same thing. Where those two points cross each other from side to side could be your center line of the car. I've done that a lot on cars that like I've built that I know the center line is squared up. The inner pivot of that lower control arm line up side to side. It didn't turn a stub like on a modified, but like on a late model, that's how I used to do it. You just drop the plumb bob off there, scribe the line, and then you're going to want to like use a chalk line, a construction chalk line, and run a line all the way through the car. And this will be the center line you're going to work off of and work side to side on. Another note is you're going to want to make sure you get the car in a very level spot in your garage. You're going to want it to be the most level spot without a lot of cracks and movement in the concrete. You don't need a surface plate, just a good level concrete area will work. In the case of where you would turn the stub on a modified, but you know you want your center line to be, and your frame is built square without taper, what you could do is you could measure like frame rail in the rear, side to side, drop a, figure out what the center is, and drop a line down it. And then on the center line of your stub, like on a modified, there's a hole. And you could drop a plumb bob off that center line hole, and that would be your center line. Whatever method you choose, talk amongst your crew, figure it out. You're going to want a center line on the car that when you start putting this data into your program, you're going to want to call that the center of the car. And you're going to measure left and right off of that center line. So whatever you figure and however you figure your car is built, like I said, a lot of people turn to stubs on a modified, which will skew your lower control arms. So you don't want to call a diagonal lower control arm mount and then put it isn't good. So you're going to want to put some sort of center line down the center of your car at ride height. Another side note I should add in right now, once you figure out your toe, some people like to square the left side, angle your right side out. Some people like when they're figuring this stuff, they toe them both evenly. But wherever you figure out you want your toe to be and you're going to start measuring off all these points, you're going to want to lock your steering with maybe some vice grips or something like that. And you don't want this, once you start scribing lines, you don't want this car to move. You know, this will probably, if you're doing it at night as a hobby, or even when I did it as a day job, it'd take me a couple days to do all this work. But you don't want this car moving at all once you start scribing lines and measuring. That's why it's important to get all your body work and as much off of it so when you're crawling around on this thing, you don't actually accidentally bump it and it'll throw all your measurements out and you'll start all over. So whatever you need to do to make sure that this car will stay exactly as you're setting it the entire time you're measuring is very important. Another thing I might add in there is, of course, the obvious, not only the toe, but make sure all your casters and cambers are set in the car. If you're going to probably do a rear setup too, so make sure all your rear ride heights are correct, all your bar angles are where your neutral positions are. And then what you can do and what some programs, like I said, I haven't done it in so long, what some programs do is you can change bar angles and heights. You're going to want to know at least a starting point in the rear. And then when these programs now will allow you to like roll the car down or dip the car and roll it and do all these things, and you can watch migration, and they're pretty good. Right now is a good time to mention exactly what I used for software. Back in the day, the premium software, this was like I said, early to mid 2000s, it was called the Bill Mitchell program. All the NASCAR teams used it, and actually, when I went to that school with that Formula One engineer, he was developing his own software. But all the NASCAR teams that were there and I talked to, they all used the Mitchell program. Matter of fact, the two Ganassi engineers that were there had their laptops there, and the Mitchell program was on their laptop with all the cup stuff on it. So I knew they were using it. At the time, the Bill Mitchell program and his algorithm for figuring all this stuff was the best. So that's what I got. It wasn't cheap, but if you're going to go through the time and doing this stuff and all the headaches, don't cheap out on bad software. Because the algorithm, to put it in there, to put all this data in there and actually figure initial roll center is easy. I mean, we can do that on paper. The hard part is the algorithm that the software uses when you start rolling and diving that thing, where that thing migrates side to side, your instant centers and everything else. At the time, the Mitchell program had the best algorithm. So I would suggest looking into the Mitchell program and then looking into some others, even if you could find out what the top teams like in the country, pro teams are using, what everybody's kind of using. If you get your ear to the ground a little bit and find out what they're using, that's probably the direction I was going. Um, like I said, I bought the Mitchell program, but then that Formula One engineer, this was back in I think 2003, 2004. I went to his school and he was developing one at the time, but the algorithm wasn't right. So he was having trouble and he would not release it without stuff being right on it. And he had a model of it there on the laptop and he showed us and he played with it a little bit. But he's like, yeah, there's just some things I got to work through with it. So work hard on the software you're gonna use with this thing and get good software. Other than the software, the next set of tools I guess you're gonna need to do this is you're gonna need. I always had two or three plumb bobs in my box set up with strings at all times. I used to plumb bob a ton of stuff, measuring stuff, used them like tools. You're going to want to get yourself a floating laser level of some sort, not just one you put on the ground that projects a line. You're going to want something that's gyroscopic. So when you set it on the floor, you're always going to get that 90-degree line vertical and then probably some sort of horizontal, but the vertical line is the important one. So when you set that laser line on the floor, you turn it on, it'll find 90 degrees, it'll shoot a curtain right down the middle of the car. What that will do is once you get your center line on the car, you're going to want to basically figure 90 degrees out from that center line and draw a center line across the center. And that will be the center line of the front end. And then when you start measuring, you're going to drop a plumb bob off your ball joints, off your spindles, and you can figure out how far offset that front end is for lead and everything else. But you need a good solid center down to center with a curtain so you can measure your upper points, you can measure your lower points to this laser curtain going down the center of your car, because you're going to want to measure not only up from the ground and over from the side, you're also going to want to measure lead. So you're going to want to plumb bob down, measure 3 axes on this thing. Every point you're going to fill out on your software in a 3D program will have 3 axes, X, Y, and Z. So every point you measure, you're going to need basically 3 measurements. Each software is a little different. So you're going to want to get, like I had I think it was a 3 or 4 page deal I did with the Mitchell program. And it was just a big thing: upper ball joint, lower ball joint, inner pivot, steering components, rear end, center line, You fill out all these points, X, Y, and Z, and they'll define them for you where they want them measured. But you're gonna want a good laser. You're gonna want plumb bobs, and then you're gonna want a good way of measuring it, other than a tape measure. What I bought off of, I think it was Amazon, they are steel rulers and they are divided up into decimal points. So when you're measuring from your curtain down the center, you can hold it right up to your ball joint center line. It'll give you a rough decimal point of where this thing is. So you don't have to take a fraction with a tape measure that might be inaccurate. You have a steel ruler, and I think I bought one, a short one that's real flexible so I can get it in tougher places. And it was like a spring steel. You're gonna wanna get, I had a short one, maybe 18 inches, 2 feet long. And then I had one that was like 3 feet long, and it was for measuring longer distances. You're going to want to get yourself a couple scales that read in decimal points or whatever you need to figure out. You don't want to use tape measures for this thing. You're going to want your steel rulers, your plumb bobs, your laser deal. Keep a tape measure with you, of course. You're going to want to build your tire stanchions. And after you get all your tools rounded up, then it'll finally be time to start actually measuring this thing. Okay, now that you got all your tools assembled, I had mentioned that laser level with the curtain that goes down the center. What you're going to want to do is set this thing up in the front of the car. Sometimes I had to turn out, I had a shop that had like part of the shop was lit and you could turn out half of it. So you could still walk around and look, but it was kind of dim in there. So you can see the laser real easily. And as you get working through it, you'll build your own system. You'll get to understand a little better exactly what you need. Probably going to want somebody to help you with this and work as a team. You don't want a ton of people walking around the car, bumping the car. Maybe just two people do this on their own. And you're going to want to start measuring. You want to take that laser level and set that. Now, if you got your kind of your points where you want to, and you got your line snapped, you're going to want to set that laser right on that line. You have to move it around and tilt it and get it so it projects all the way through your car on the center line of that car that you chalk lined. And that will be the center of your car. Make sure it always stay there. As you're walking around, you may bump it. Make sure every measurement you take, that laser line, that laser curtain is on the center line of that car. It's still working, floating good. And then you start measuring. You get your sheets ready on a clipboard or whatever, and you just go through them with your measuring partner, and you start measuring all these things. You can drop a plumb bob off the ball joints and get on the floor and measure. That's what I used to do. I used to, like, if I'd be measuring an upper control arm pivot somehow, sometimes I'd drop a plumb bob off of there. And then I'd put a little pencil mark on the floor, and then I'd measure with that ruler to the center. Sometimes if you're measuring up in the air like that, it's difficult. Sometimes you have to do it, sometimes you don't. There's a lot of variables there. You're going to want to work out on your own as you're doing this and figuring out the best plan. But you're gonna want some way to measure to the center line of that car to get your distance out, your distance up, and then the distance off your diagonal or the cross line 90 degrees to your center line. You're gonna want to figure out the distance ahead or behind that to figure out your lead. So you got a lot of measuring to do. Ball joints. They want you to measure on ball joints what they call center of pivot. When you're looking at a ball joint, how do you know what the center of pivot was? I had a kind of a system with the house stuff, and I don't remember exactly what it was, but it was like if I measured to the like a center line that Howell had in there, I took them apart and I looked at them and I figured the center pivot was right there. And I almost thought I used to use on the house stuff like the bottom of the cup for a screw-in ball joint, but you'd have to look at your ball joints, maybe call Howell Racing up if you're running Howell ball joints. Figure out where they recommend the center line is, and then kind of do your measuring from there. Ball joints are a tough one. When we were running stock production ball joints, I actually bought a set of ball joints, cut them apart, looked at them, and kind of figured out where the center rotation was on the ones that were in the car. So that's an option too if you're running stock ball joints. Take them apart, cut them apart, whatever you got to do. Buy an extra set so you can figure out where the center of pivot is on those ball joints. Another cool thing a lot of these programs did now, and the Mitchell program did it, and I used it a little bit, but I didn't get into it as much as I probably could have or should have. And it allows you to build parts and then assemble them on the car. Like you can, if you're running one set of spindles and you want to run a different set of spindles, you could actually measure spindles, which I've done quite a bit, and then take that spindle and then put it in the program. I never inserted them in the program. I used to just measure spindles from different manufacturers so I'd know a kingpin inclination. I learned a lot about spindles over the years and what was running where and what was running what. I did input it in the software a little, but I really never got very in depth with it. But a lot of these software programs now will have options where you can just measure the car, bolt a different spindle on there, and figure out what everything is happening with that different spindle. Like I said, it's been many years since I've done it, and the software used now is probably a lot better than what I used to use, but the potential might be there. So I guess let's go over the drawing board. We'll draw some diagrams, and I'll kind of define stuff a little better with some diagrams, and hopefully everything will get very clear and set you guys on a good start to finding some roll center stuff. Okay, the first thing you're going to want to build are the tire stanchions. Like I said, it's very important that you figure all this stuff with the weight fully in the car, so you figure on tire squish. Because it's really easy to pull your motor out and then you got an easy way to measure around it, but then you're taking so much weight out of it, the tire squish isn't the same. So what this is right about here and here would be where your studs are for your lugs. And this is the center line of your hub. So what I did is I took some tubing that was cut out, like if you run a 5/8 stud, it was a 5/8 OD, and it would go on there and use a lug nut. You bolt this on your car. This will also be angled a little bit so that these run straight down and these pads here fit square on the floor. This will have to be tilted to run at your camber you're going to run in the car. These are kind of difficult to build, so I don't know if you have any good ideas where you can actually like swivel these. I welded these all together with the proper camber. I put feet on the floor. I guess you could run these off of rod end joints, so this would sit flat on the floor and this would pivot. That would be a good idea too, but this is how I built them. Two places to bolt your wheel studs, 1-inch tubing down, 1-inch tubing across, some little feet. The center line is cut out, so if your spindles let a little bit or whatever happens here, you always have a place to mark and measure plumb bobbing down off your different points, whether it's your spindle will be a little offset with the caster, but you're going to want to leave the center pretty well cut out so you can mark and measure through here pretty easily. These might be some little braces or something you might want to put in there to keep this from flexing. You're going to want to build 4 of these, 2 for the back, 2 for the front, And this is going to be one of your biggest deals. Next thing you're going to want to build, and I think I mentioned this before, it might be in one of my other videos, but ride height bars. Something you can bolt in place of a shock and a spring or whatever. I used to use 3/4 tubing, 65 wall, I believe, and it would fit a half by half rod end in here. I'd get two jam nuts. You get a left and a right. Then you get two jam nuts for each, and you could just tack weld one jam nut onto the tube, and then you'd have the other jam nut. It would act almost like a tie rod where you could thread it in and out. Or if you wanted to, you could go buy, aluminum tie rods, steel tie rods. But I used to just make my own. Like I said, left and right, half by half rod ends with two jam nuts, pieces 065 electric weld tubing, 3/4 inch, and you just tack them together, and that works really good for a ride height bar. Take your shocks and springs off, shocks off, take your springs out. If it's a mod, you're going to pull them out of the cups, and this is how you're going to set ride height on your front end. And I thought I'd draw just a little diagram. It's a horrible diagram, but it'll kind of give you an idea on what's going to go on here roughly. This is the center line down the center of your car. Of course, it's not good. I mean, I made my left rear axle tube longer than my right, which is backwards, but yeah, you'll get the point. Then you're going to want to put a line across your front end that is 90 degrees to your center line. If in a mod's case where you twist the stub on this side, this would be your lower control arm inner pivot. On the left side, it might be lined up. On the right side, it might be turned a little bit, so your inner pivot is ahead of the line, behind, and then you're going to pull caster in. So, your outer pivot where your ball joint is might be a little ahead. Maybe you'll pull caster with your upper. However it works out. Maybe the upper will be behind and the lower will be ahead, whatever. These will be strut mounts on like a late model on a mod, and some late models now will put the strut behind, 60-degree front end type of deal. So your strut mount will be probably back here. And you're going to want to measure all these points. Like I said, this is a top view of what you'll be measuring, but I kind of wanted to point out that the laser, I always put it at the front. On cars that were, I had trouble seeing the rear, as long as I had that chalk line here, I could put the laser sometimes in here if I was measuring the rear. I just had to make sure that laser stayed on that chalk line. And then J-bar bounce, you're going to want to measure and leave yourself room to measure all this stuff in the rear and all your suspension pickup points in the front, keeping in mind what you want to find out, whether you want to find out if your stub's turned. You're going to have to work out kind of in discussion or in your own mind exactly where this center line is and where you want this line to be. And then measure everything off that. These two lines, very important, need to be perpendicular to each other. This has to be 90 degrees for all your measurements to roll out good. If it's not 90 degrees, you won't be able to tell if your stub is turned. There's a lot of things to this. So make sure wherever you draw this line, it is 90 degrees to your center line in your car. So these are probably going to be your two most important lines, and I used to chalk line these, both of them. So I knew when I got done, I'd use a clean floor, and I'd take and put pencil marks or even Sharpie markers if you really didn't care about marking on the floor. But you're going to want to put marks on the floor and plumb bob down, and it's going to take some work, but this is kind of an overview on what it will look like when you kind of get moving through this process in your mind. One very important point here I wanted to make sure that you got, I forgot to put it in the beginning of the video series, is make sure whatever program you choose to use, you get good documentation, you get good support. With the Mitchell program, when I bought it, came with a book that was thick. And then he had written another book with a guy that was excellent that I bought too, and it was about that thick. And I bought one book, and it was probably around $100. And another book came with the software, but it was excellent documentation. If you run into any snags on how to measure this stuff and how to look at this stuff, make sure you read through that documentation because that will iron out any problems you might have. Very important. Choose a software with good documentation and good resources coming with it. You don't want to buy software that, oh, they claim to do this and that, but there's no documentation. So make sure what you get is good and is going to help you get through this process. If you liked this video and you thought it was useful and like the other videos, you can subscribe to the channel. And then if you ring the bell, they will notify you when I put more videos up there. And it's not nothing spammy you're going to get in your email. But when you log in to YouTube and you want to watch some videos, it'll say, this channel put up a new video, check it out. So that is the notification if you subscribe and ring the bell. So I guess we'll see you in the next video.